Hello, part 3 of proposition 4. Good. So far, remember, we're proving coincidence in order to prove equality. Two figures that coincide are equal. We see that directly. So if we can show, when we move this over here, that everything coincides perfectly, they're necessarily equal. Great. We've already proven by little reductio ad absurdums that this line together with its 2 points coincide with this one, and that this angle coincides with this angle perfectly when you put them on it, because this line will necessarily coincide with this line. Point, line. Now we have to prove that this point also coincides. And you say, gosh, that's obvious. We really have to do that? Yeah, because this isn't simply something of the imagination. It's something that the intellect has to see, okay? So we say that it does, and Mr. Smarty Pants says, no, it doesn't. I heard about Father Tony saying I can use my intellect. I'm using my intellect, and I say it can be 3 things. It either here longer or falls shorter, and I don't see how it necessarily falls right on top of it. Okay, Mr. Smarty Pants, says you, because you're getting good at this now. You say, let's say then, Mr. Smarty Pants, that it falls a little bit longer. You willing to say that? I'm willing to say that. Okay, well, if it falls longer, Mr. Smarty Pants, then we know that the whole being greater than the part, that this line is bigger than this line, right? Yeah, it's larger, obviously. The whole is greater than the part. I see that. Well, if it's greater than it, they're unequal. Obviously, it's unequal if it's greater than that. But Mr. Smarty Pants, it was given that they're equal. Do you want to say, Mr. Smarty Pants, that it's equal and unequal? No. Well, what are you going to say? Okay, well, I say that it falls short. I obviously it doesn't fall longer, it falls short. Mr. Smarty Pants, if it falls short when we put it on top, then this whole now is going to be greater than this part. This thing is now a part of this. That is to say, this line is unequal with this line. What's wrong with that? But it was given that they're equal, remember? Oh yeah, that's right, I remember that now. Well, you want to say they can be equal and no, I don't want to say they can be equal and unequal. Then what are you going to say? Well, if it doesn't fall short and it doesn't fall further, you're right. The only other option is that it falls that point right on top of that point. That which has no part falling on top of that which has no part. I can't imagine that. Mr. Smarty Pants, it's not about imagining. It's about the intellect, what the intellect's... Oh yeah, that's right. Okay, she got one thing. All right, Mr. Smarty Pants, now we just have to prove that this is coinciding with this. That this line perfectly coincides. I say it coincides. I say it doesn't. Okay, Mr. Smarty Pants, if it doesn't, what do you want to say? That it's... It goes like this. If it doesn't coincide, it must fall off, right? Right. You only make it fall off, it like the line curves or something like that. Well, maybe, yeah. But it's a straight line, Mr. Smarty Pants. It's an equilateral triangle, straight lines. Okay. Well, what if it falls inside? Same thing is going to curve, Mr. Smarty Pants. If it doesn't do that, doesn't it? All right, it does coincide. Well, if it does coincide, then the whole, all 3 sides coincide. No, sorry, that's your accent. This is my accent. If it does coincide, all these 3 sides and the points coincide, right? So we have perfect coincidence. Right. Therefore, we have equality. Right. Hey, thank you very much. I appreciate it. I appreciate that. No, I'm sorry. I appreciate that very much. So if it coincides, then you know the angles coincide, and then we'll say this little red one here, 2 red lines, the angles corresponding to that are also going to be equal. So that equals that because you have coincidence. This one here, subtending this side, which is equal to this side, the angles are necessarily going to be equal. And this one was given to be equal, but look, this one subtends this. That's always kind of important for later. You have to say, okay, which one subtend which? Oh yeah, these 2 are equal. Good. So now you have proposition 4. I think you have a much better idea of what it means to be a reductio ad absurdum. Basically, you grant a thing that's false and seems kind of dumb to say, but it's understandable, and you reduce it to something that is obviously stupid to say about equality and not equality at the same time in the same respect. And that way, if that's false and everything else you said was true in the argument, the thing you granted at the beginning must be false. If this is absurd, you did something wrong in there somewhere. Oh yeah, it was the thing you said in the beginning. That's what a reductio ad absurdum is. Thank you so much. God bless you. Bye-bye.